the other day, and I put it on ones that I saw. Okay, so these are the equations of motion, and we have 4 of them, and you will get them in a data sheet. Okay, now I'm going to just talk you through these. Now remember, the VR we already saw yesterday or the day before, was initial velocity. This is the velocity at the very beginning. Now, you might see in some textbooks or online, you might see that it could also have the symbol U. And if you look on your data sheets that I've given you, you should see that they give you 2 sets of these. They give you the sets where I'll give you these symbols, and then they give you the sets where I'm going to show you what the other symbols are. But they mean exactly the same, and you can use either. Okay, I'm going to use these ones because it makes sense that the VI is initial and not a U. Okay, then we have VF is your final velocity, so at the end, and in the other notation it is just a V. Okay, so you'll see 2 sets. Let me see if I can find the SAGS document so I can show you. I will, just so that you understand what I'm meaning here. Grade 12. Okay, I'm going to share this with you guys now. I'm just opening it. Okay, I'm going to now show you the SAGS document. I am going to give you a copy of the SAGS document next year. Okay, I didn't want to overwhelm you this year with it, but it's a very great document, and it will tell you exactly what you need to know, and then you can also keep me on my toes with that. But I promise you I'll follow it word for word. Okay, I don't know why I'm doing that. Right, let me show you this. It's the first time I'm showing you the SAGS document, I think. Okay, so this is a document that every subject has. So you can ask for any of these. You can even download them yourself. Okay. Can you guys see? Hey, you online at home? You can see?
Yes, ma'am.
Yes, ma'am.
Okay. So you'll see here, this is now a 3-year plan. So that's why you have started some of this, okay, already. Because by the end of grade 12, you need to know all of this stuff so that you can write 2 3-hour papers at the end, okay? So you can see what's required. You can even see that we go strictly according to areas. So I've just set the matric prelim paper and make sure that there's about 50 marks worth of kinematics. There's 30 marks worth of electric circuits. So I do this for all of your tests as well. Tests not so much, but exams definitely. Okay, ooh, okay, so tests not so much, but exams definitely. Because tests sometimes, I mean, I only test you on one of the sections, so it's hard to do that. But what you can see is how is your different types of questions get divided as well. So you can see here knowledge and recall. Now, girls, this is definitions that you need to learn off by heart. Anything that you need to recall from what you've studied, that is 15% of your mark in an exam. So you can get 15% like this if you just know your stuff. Okay. Then comprehension and routine exercises, those are the more simpler things. One, like you just have like a, what's it called? Sorry, I was just listening from my end. Like a, you get asked to calculate something and you use one formula, you substitute correctly, you get an answer. Okay. Or I give you a graph and you have to read something off the graph. Okay, that's what comprehension and routine exercises. And look at that. For chemistry paper, that takes you up to 55% of your paper is just that. So if you can just do those simple things, you could get 55%. Okay, and I'm very strict when I set papers. Right, I do them like this. And then the application analysis and synthesis and evaluation, those are the more hectic questions, those are, you've practiced similar questions, and now I give you these questions, and you have to try and apply your knowledge and understanding to something that you haven't seen before. Okay. Synthesis and evaluation is the most difficult to set because these are hard to come by questions. But these are questions like when I give you something and I say, Mary said this, but John said this. Who is correct? And then you have to evaluate both of these statements and correct it if it's not correct. Or I say, here's a statement. Tell me which parts of it is correct and which parts of it is not correct. Okay, can you see how that's more hectic? Synthesis is something like draw a free body diagram. You've had to come up with it by yourself. All right, so those are those. Okay, so anyway, let me get back to, okay, so this just tells me what everything means and what you need to do and all the documents. Okay, yeah, this is where I want to go. Okay, so these are the data sheets that we get in the SAGS document that I've given you already, hey? I have given you these. So let's just take a look here. I want to get to the first page. There we go. So you can see here, right at the top, on motion. So you now are going to be able to know what these are. But you can see that they've got this form, and then they've got that form. No, that didn't, there we go. And that form. So we've got one where there's a U in it, and one where there isn't. One where there's an S, and one where there isn't. So you can see how they can interchange. They mean exactly the same thing, except some teachers teach it using S's and some teachers use it using X's. I used to teach the S's and then the curriculum changed and then we're using X's, but the IEB doesn't discriminate. Okay, they're happy with either. So you will always use the second equations. And then you can see they're exactly the same. Let me just make it bigger here. You can see how they're exactly the same. If we take a look here, for example, remember I said to you the U means initial velocity, and look there, they put a VI over there. So don't get confused. You're only going to you're just going to use the second equations. They are exactly the same. Okay, so let's get back to this now. Stop presenting, and let's present again. Window, menu, share. Okay, so now we're back here. So that's why I'm showing you these. So you can see that there are two sets. We are going to be using this set though. Right, we use an X for displacement or change in position, measured in meters, always and forever. Even in chemistry, it's measured in meters. Okay, maybe not. No, it's always measured in meters. Okay, so now this is weird, but displacement in the other notation is an S, a small letter S. It's very weird. I don't know where they got that from. I learned it at school like this method. But the X kind of makes sense because we've been working on a Cartesian plane and it's a horizontal and it's a distance. It actually does make sense. T is time, obviously, and it's always measured in seconds, and A is your acceleration, measured in meters per second squared. Okay, so if you take notes, you'll see that each one of these equations has 4 quantities. Look here, 1, 2, 3, 4. It has final velocity, initial velocity, acceleration, and time. 1, 2, 3, 4. Look here, we've got a time twice. And it will be the same time. So if it's 5, then you'll put 5 here and 5 here. This equation, though, it can, if you need to work out time and you need to work with that equation, you could land up with a trinomial. Okay, but I'm going to deal with that with you next year. Okay, because next year in maths, you're going to get a formula that will help you solve a trinomial. Okay, right now, if you have to work out time, I would suggest you don't use this one. You use something else to work something else out first and then work out one with time. But you can use this one if you have time. Okay. Right, so there's 1, 2, 3, and the time is 4. 1, 2, 3, 4. 1, 2, 3, 4. Every single one of these has 4 quantities, which means you only need 3 of something to work something out. Okay, so that's what I've said here. You only need 3 quantities to solve the 4th. And girls, it doesn't have to be that you need that and that to get that. I might need to work out time and how I have the final velocity, the initial velocity, and the distance. And you need to be able to manipulate your equations. That's what I mean by the biggest problem here is maths. Okay, it's not your choosing of equations, it's not your substitution. I often get wrong answers because the math has been incorrect. So please let me know if you're backing to solve an equation and I can maybe do a lesson on it. So let's go for an example. How do we start this? So it says here, an airplane needs to reach a speed of 60 meters per second to become airborne. Okay. The engines allow the plane to accelerate at 5 meters per second. I wonder if I hide this, if it will stop flashing. Is it annoying? There we go. Okay, so, and the runway is 800 meters long. Now let's just break this down. So an airplane needs to reach 600 meters per second. Let's just read the first question. It says, how long will it take for the plane to reach the speed of 60 meters per second? How long will it take? What are we looking for? Time. Okay, we are looking for time. And always just write it above where you are. Just put a T there. We are looking for time, and that is our question mark. How long will it take for the plane to reach 60 meters per second? What would our 60 meters per second be? We know it's a velocity, but is it the initial velocity or the final velocity? The final velocity. Okay. What else do we know? We do know the initial. The initial wasn't said to us, but we can assume the initial. What would the initial be? 0, absolutely. The initial would be 0 meters per second. All right, even though it doesn't say from rest. From just our general knowledge, we know that an airplane must start from rest and then speed up. Okay, so what else? So I have 1, 2. I don't have time. I'm looking, so I need one more thing. Why would I not want to use that runway though? Why would it be better to actually just take the acceleration? Why am I not going to use the runway as the distance? I'm glad you actually said that. It just said the runway was 800 meters long. It didn't say it takes the plane 800 meters. Okay, so that's a very big, you have to read your questions carefully. So even though you are given a distance, this wasn't the distance that the plane took to get there. This is just how long the runway is. Okay, so be careful. So here is our third thing. We've got 1, 2, 3 things. We can work out the 4th. Okay, so what I do now, I always carry my equations around with me because I never remember them. Okay, so let's take a look. Which one do you think would be the good one? So we want something with a T and a VF and a VI. I'm heading towards this one. We have a VF, yes. We have a VI, yes. Oh, sorry, wrong way. That's the, sorry, it's the grade 11 one. I need to turn it over. Your one's on the back, except my press stick has made a mess now. Yeah, but you really can see them at the top of your page. They really are there. Sorry, I was busy with the G. Oh, you can see I've made a mess with my G's here as well. Okay, so here we can see I have a VF, I have a VI, I have an A, and I have a T. Those are the 4 there. So when you've identified the 4 quantities, you then can identify the correct equation that you need. It has to just have the 4 one. If you find you can't find one with all 4 in it, you might have to use another one first to work out something that will help you work out the thing you want to work out. So you might have to use 2 equations. So let's take a look. So we write down the formula first. VF is equal to VI plus AT. Girls, I'm not going to give you a mark unless you write the equation down. All right. And another thing, If you just write the equation down without any type of substitution, you also you're not going to get it. So even if you don't know what to do and you write down the correct equation and you put Fong Kong ones in, you put any values in, you can get a mark for the equation. All right. Okay, so let's take a look. My VF was 60, so be careful here. A lot of people tend to swap the VI and the VF quite easily. So you've got to be awake when you do this and make sure you do the right thing. It's always better to label your stuff, and also you can write a list of the things that you have and what you need, because that really does help. Okay, so my VF is 60. My VI is 0. My A is 5, and I'm looking for my T. Now we are going to do maths, but now that's nice and easy because my VI is 0. If my VI was not 0, I would first have to take that over and subtract it, and then divide by 5. But because it's 0, that whole term just disappears. Okay, so I get 60 is equal to 5 times T. What is 60 divided by 5?
Wow.
Yes. I think we were all like, this is a serious question. Okay, so we've got 12 seconds, and there it is. It took the plane 12 seconds to reach the 60 meters per second. It's not too bad, hey? And it doesn't really get any more difficult than this with equations of motion. The only tricky thing that's coming up are the graphs. But I promise you, girls, oh, please just listen to me and you'll be fine. I swear you will. But you just have to listen. Okay, convert 60 meters per second to kilometers per hour. Does anyone remember how to do that? Yes. It was times, eh? Yes. Yes. Times 3.6. What's it times 3.6? Remember I did that whole thing with you? Look in your notes. What page was that on? 5. We did the conversions. Okay, do you have it? Girls at home, you see it? Page 5, we did it. Okay, and to go from meters per second to kilometers per hour, we times by 3.6. Remember, it was the whole thing that going, you have to convert from meters to kilometers, so that's 1,000. Then you've got to go seconds to hours, which is 3,600. Okay, remember that. So that's where it comes from. So what do we get here? Times 3.6. 60 times 3.6. 216 meters per second. Okay. So that's 60 times 3.6. That's all you have to remember. You don't have to remember all that whole calculation that I showed you. You just have to remember, are you timesing or dividing by 3.6? Right, determine by calculation whether the runway is long enough for the airplane to take off. It's a very American question because we just say airplane, not an aeroplane. Okay, so can you see now why I've included the runway length? Okay, so what do we need to do here to prove that the runway is long enough?
How long the plane is going to be.
All right. Daniela said, yeah, that we need to find out how long it's going to take, how in meters, for the plane to take off. Okay, and that is perfectly fine. So if we take a look at our equations again, okay, I'm sorry, I know this is not a nice equation thing. I'm going to have to rewrite this. So we have now another thing. We have time as well. So we've got 4 quantities, and we want to work out one. So we want X. So let's see, we want to try and get one that has it in the first place. So we have a VI, and that could make that 0. We have an acceleration, we have the time. So we could use that one. Let's see, can we use this one? We have a VI, we have a VF, we have a T. We can use either one of those two. We can actually use this one as well if we want, but why wouldn't I bother using this one? Because the x would have to then make work for ourselves. Okay, so we can use either one of these two and either would work. Let's go with the second one maybe. So we have the change in change in position, or also known as displacement, a half VI plus VF times T. Okay, and that would then be, we have 0 plus 60, so we just have 60. Sorry, and our time was 12 seconds. Now, girls, I really don't need to see steps. Please don't give me steps. I don't like steps. It's one of my pet peeves, because in science at least, because that's when things get messed up. So if you can put something one shot in your calculator, do it. Okay, so this will be what, 30 times 12. You can put the half times the 60 times the 12. And just give me an answer. 360. Okay, but now remember, there was another question here. It's not enough that you just said 360. You have to now answer the question. Was the runway long enough? Yes, it was. Okay, so you can say the runway is long enough. You have to then answer the question, otherwise you're going to lose a mark. You have to interpret your answer and say, yes, the runway is long enough. Okay. These questions that we've just done now, those would be your routine questions. Okay, so they would be the comprehension type questions. All right, let's take a look at. So a cyclist moves at a velocity of 10 meters per second over a straight horizontal road. Okay, they show that it's going at an angle, but I think they've just, I actually took this from the past paper. So they're telling you it's horizontal, so just pretend that the picture's skewed. Yeah. At an acceleration of 1 meters per second. So he's moving at 10 meters per second. After 20 seconds, the road changes into soft gravel. The cyclist comes to a standstill after 10 seconds and a distance of 20 meters on the soft gravel road. Okay, so let's just break this down. So we know he's traveling at 10 meters per second over here. He is accelerating at 1 meters per second. Okay, after 20 seconds, so after he has been riding this nice smooth road for 20 seconds, the road changes to soft gravel. So can you see there's a split in our values now? Okay, so we know he started his journey into the soft gravel road. Well, we know we're going to, we know he's accelerating, so he's getting faster and faster and faster. So he starts his journey here and he's accelerating, and he moves along this for 20 seconds. Okay, the cyclist comes to a standstill, so he rides here for 10 seconds. Okay, he rides on there and he lands up with a final velocity over here of 0, because he lands up at a standstill. The distance of 20 meters in the soft gravel, so he went for 20 meters. So that's what I want you to do. I want you to write all over your page, okay? But make sure it's properly, like not just covering things up that you, and then you write it wrong and then you confuse yourself. Okay, but now I've deliberately separated these two because I can't use these values for this part, and I can't use these values for this part. Okay, we've got two separate motions here. So prove that the velocity at which the cyclist enters, oh, that S was supposed to go there, the soft gravel road is that. So we want to know then, if my initial velocity was 10, and he accelerated at 1 meters per second, for 20 seconds, I want to prove that the final velocity is 30. Okay, now there's a reason why you get questions like this. It's actually a selfish question for teachers, because The problem is that if you get an answer wrong in these questions, we carry your mistakes. So if you get a wrong answer here, but you use it correctly in 2.2, you have to get all the marks. And teachers hate doing that. So what they do is they say, prove it's that. And then, for the next one, you have to use the 30 because we've told you. So even if you don't get it right, you're going to use the correct answer so that we can mark this one easily. Okay, so it's a pure selfish thing why teachers do this. Okay, so prove that it is that. Now, when you have to prove something, I want you to pretend that you don't know what it is. Okay, pretend you didn't get that. Just calculate that. And if you get it, bonus. If not, then you've done something wrong. Okay, so it's like giving you the memo and saying, now do this question. And then you check your memo. That's what it's like. So please don't use the actual answer to prove something else. So don't use this 30 meters per second as a velocity and then prove that the time was 20 seconds. Okay, don't do that. That's a wrong way to do that. So rather than we've got an initial velocity of 10, we've got an acceleration, and we've got a time. What are we going to use? So we've got an initial velocity. We've got time. Oh, perfect, the first one. Okay, we are trying to get our final velocity. So VF is equal to VI plus AT. Okay. We know the initial velocity is 10. The acceleration is 1. The time was 20 seconds. Okay, because we are looking at the first part of the motion. Because they said, what is the velocity with which he enters the soft gravel with? Which means that it's the final velocity of our smooth road. Okay. So we worked that out. That is 200. No, what am I saying? 30. What am I saying? 200. I was timesing, that's why. Okay, and that works out great. We got the answer. Okay, so that's what you do when you're asked to prove something. You're really just working it out and you already know the answer. Okay, is the acceleration of the cyclist on the gravel road positive or negative? What is he doing as he enters the gravel? He slows down. Okay, so he slows down. It also says that he comes to a standstill. So he slows down. That is a negative acceleration because he is decelerating. He's slowing down, therefore it is a negative acceleration. So he is slowing down, therefore it is a negative acceleration. You can say a deceleration. What's another way that I could have a negative acceleration? Remember, acceleration is a vector.
If you change direction?
That's exactly it. If we change direction. So if we accelerate, so we're going faster, 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 but in the negative direction, it would be a negative acceleration. Now, here's a question for you. What happens if I decelerate in the negative direction? What will my acceleration be, positive or negative? So I decelerate in the negative direction. It does become a positive. That's exactly what it does. Okay, so let me write this down, what I said. So if we're in the positive direction, okay, and we speed up, right, we will be a positive A. If we slow down, it'll be a negative A. Okay? If we're in the negative direction and we speed up, it's actually going to be a negative acceleration. And if we slow down, it's going to be a positive acceleration. And it's exactly like maths. The negative of the direction and the negative of the slowdown cancel out. Now, this is hard now to say, if I give you an acceleration, how do you know if it is speeding up in the positive direction or slowing down in the negative direction? It will be determined by the question. You will be able to distinguish by what the question says. Okay, so for example, we know that there has not been a change in direction here. Okay, and we know that he is slowing down. And when there's no change in direction, we can choose that direction as positive. And so we're in a positive direction and he's slowing down. So that negative acceleration is because he's slowing down in a positive direction. Yeah.
If I write down my equation,
Mm-hmm.
then I did something wrong
If you chose the correct formula, then you get that. If you substituted correctly, you will get that mark. And if you give me a correct answer with the correct unit, you will get that mark. So let's say you see the problem is that it also has to be mathematically correct. So let's say you did something wrong with the substitution, okay? But you knew the answer was 30. So even though it didn't give you 30, you just put 30, you won't get the mark because it doesn't work. That does not equal that. See? But if you if your substitution was correct, but like me, I nearly multiplied them and say you got a 200 here, you would get a mark for your correct formula, you'll get a mark for your correct substitution, but you'll lose a mark for the answer. Okay. Then if you use this answer in another question correctly, you will get all those marks, even though it was wrong.
Let's say the question says exactly the same, but the people are going in the other direction, 100, 90, okay. I don't know, would they still be going in a positive direction and slowing down?
It will be completely based on what the question says. So if let's say it was if this guy was going on this gravel road and the gravel road was a zigzag, you know, like down like one of those European mountains that go like crisscross, and imagine it, and then he went down there like that, and he was still slowing down, but he changed direction. So he's slowing down, so it's a negative. He's now in the negative direction, so the acceleration should work out to be a positive. Okay, that's what I'm meaning.
But if it was exactly that, and just flip over there.
Oh no, you know what? You can choose positive, yes.
Yeah. Going to the left, I think it's negative.
Yeah, no, but you know what? You get to choose your direction. So if there's no change in direction, I always encourage you to then choose the direction of motion as positive, because it's just easier that way. Then everything's positive. You don't have to worry about any signs. Okay, so even if this guy was going the opposite direction, choose the left as going positive. It's fine, because your answer will be a positive, and you know that you've chosen left as positive, and so they're going left. Okay, so it will always work out. Even if we chose this as negative, we would land up with a negative answer, and you would interpret it as going right, because we chose right as negative. You see what I'm saying? Your answer will always work. Okay, I'm going to do this one with you quickly, or do you want to try it on your own? You've got quite a lot of think tanks, so this is what I'm going to do with you. I want you to try number 8 on your own today. I'm guessing I see you on Monday, because I don't see you on a Friday. On Monday, I'm going to let you continue with these think tanks. Okay, so it's not going to be for homework. So in the last 15 minutes of this lesson, I want you to do number 8 now. Okay, and then the think tanks are not going to be for homework. We're going to continue with them on Monday. That way as well, it will help, because any girls coming to get their notes will then get their notes on Monday afternoon, and then we'll start the new notes on Tuesday. Okay. Girls at home, you happy with that?
Yes, ma'am.
Okay, so I want you to do number 8 now. I'm also going to do it. And at the end of the lesson, I'm going to show you the answers. Okay. Okay, I'm going to stop the recording for now.